Peter Haddock and I'm here at Banner with Jan from Makineo. Jan, you have been doing something crazy with wheeled excavator here that involves sensor chains from Leica Geosystems, the tablet in here, and something right above us here, which is a crazy sensor mounted to a machine. Tell me all about it, because this is your super souped up civils machine.
Yeah, thanks a lot for the introduction. Yeah, it's a world premiere release of the Autodoku system based on a Leica platform. But I will give you all the details of the hardware, and then we show you what is really, really new, because that's a scanner.
Right, so tell me about the machine. So fundamentally, what machine have we got here? It's an Hitachi, isn't it?
It is a Hitachi machine, and we call it an infrastructure machine because it had all the technologies for customer who's doing infrastructure work. And this is a 17-ton machine, so perfect for all tasks like cable or underground works, and that's a machine for it. And we have equipped it with all digital tools which you need for that job.
Right, so when we talk about digital tools, obviously we're going to go and see in the cloud in a moment, but we're talking about as-built models coming into the industry now. So as we do things, we actually see them being built. And so you're telling me that actually you can send data and information from this machine very, very quickly to your cloud-based solution. How does that work?
Okay, we go through the hardware and then I'll show you the trick, how it works. Because what we do, this machine is an excavator.
Yep.
But with this attachment, it's a scanner. It's a scanning tool like a drone.
Yeah.
While working, you get all the 3D data. So let's have a look at the hardware.
Okay, come on.
So what we have here is a machine control system.
Yep.
So we are working with a Leica MC1 control system.
Yep.
We have here the laser catcher, the hardware inclination sensor. On top, there's another one. And this sensor is a triple use case. That's the funny part. So one of it is working for the machine control system.
Yep.
The second is we have here a safety system with a dynamic scale, and we are using the same sensors. And the beauty of it, we use it also for the scanner. So the customer has just one set of sensors, but 3 applications. And these are the sensors.
And so what's interesting about that is it's a true partnership between yourselves and Leica saying, we wanted to change something, and how can you help us put it all together and create this new kind of approach, isn't it?
Absolutely, because we are not just a dealer for Leica, we also have a development partnership. So what we did here is using standard sensors, but together with Leica, we open them up for other applications. And that's brand new, because no one else can do that, what we did here.
So the brand new is happening right now. That means it's probably scanning me right now. In the cloud I go. But really what's exciting about this is when you look at the back end. So we've got the machine, we can see it there, but let's go first into the cab and see how that all works for the operator. So Jan, I'm now in the machine here. There's a great visibility on this machine, by the way, and I've got the tablet in front of me. Why is it important now that this whole system connects up? What am I going to see as the operator?
Yeah, the idea is to have maximum visibility on the technology, but still a good view out on the construction side. So we have here a machine control panel, the Leica MC1 display.
Yep.
Next to it, you will see another display, which is our Copilot system, manufactured by KTEG, with a dynamic scale on it, with a 2D system and passive fencing. So you have a safety issue there, and we have the completely tool management on board. So we have tool trackers on the attachment, and you get all the information of the attachment connected to the machine. So depending on your attachment, the machine will start the hydraulic pressure, whatever you need to work with this attachment. And that is a technology, you have a tool tracker on it, whatever attachment it is, and the machine adjusts to this attachment, and then you're ready to go. No pushing button, it's an automatic process, and I don't do any mistakes on the machine.
Fantastic, and of course, you've got that semi-automatic system from Leica available to go onto it as well, haven't you?
It's more or less standard already.
So, when we're wheeling ahead, folks, here in technology, this is really cool to see how we're combining lots of different things to make this the ultimate civil engineering dream of a machine. Great to see you, but wait. Let's go and see.
I have another question. How do you like the displays? Is it good? Is it Do you need more, less? What do you think about the displays?
The displays are in the right spot, so it gives me the fun visibility that I need to actually do my job. It's placement in the cab that's really important. Yeah.
Do you think we can improve?
Well, we can always improve everything in the job site.
Would you like to see it today?
Really? We're going to improve it already, and we're just showing it here.
Let's go over there and I show you the solution for it.
Right, it's all changed, even though it's brand new. Fantastic. And here is the excavator, and we've got lots of blue flashing lights everywhere, because what is this actually showing us?
Yeah, it looks like a toy, but it isn't. As you see, that's exactly what we've seen on the real machine. We have the sensor chain, we have our scanner, and here you see the working discipline. So you're working here and you see the scanning area where we gather data. The blue dots are laser beams, and these are the working principle, and we show it in the cloud what type of data is gathered.
So now we know where the pipes are, we know the depths of the pipes, we know exactly where they are for our finished model, so that if we have to ever repair something like this, we're not digging into them. Brilliant. So come on, let's see it in the cloud. Come on,
let's go for it.
So we've just scanned it outside. Here's the point cloud. What's the level of accuracy?
1 to 2 centimeters, like GPS accuracy.
Fantastic. Now we're going to go and see how that accuracy actually benefits us when we're talking about the job site in particular. Come on, over here. So we talked about the 2 tablets in, and you confused me there because you're like, are you happy with it? Well, I'll just cab clutter with 2 maybe, but this is the all-in-one, isn't it? Tell me about it.
This is the all-in-one display. So whatever application or digital assistant system you have, we bring it on one screen, and that saves a lot of visibility and everything. So this is our new concept. All the systems work on one display.
And we've got some really cool joysticks as well that even keep your hands warm.
They keep their hands warm, they vibrate, and they are tailor-made for the customer need, operator need. So he can change the functionalities of these joysticks to his needs.
So let's see how we measured that volume elements before, how that works, and then I'm going to do something really cool by measuring my own volume of what's been dug. Fantastic. Come on, let's go. So now, folks, we've got all that information. That information can turn into data like this, and now I'm going to do very quickly a volume calculation. Look, so here I go. This area here I'm going to select in random, volume calculation, then comes out from there, and I double click that. There we go. And there it is. We've done the volume calculation, and that is how all of the systems come together to actually make the industry work. Great to see you. Cheers. Thanks a lot.